Hello everyone, welcome to Fixtronics. So today we have this power supply from Dell, and this power supply is not working at all. So when we have, as always, we say that when we have a power supply that does not power on at all, the first thing we check is the fuse. So in this power supply, the fuse is located here. This is the fuse, as you can see, it's this one. So in diode mode, if I short the probes, we get a beep. So we test this fuse and it's blown. This fuse is blown. So why this fuse is blown? Maybe there is a short circuit in the primary side. So the primary side is from this transformer this way, and the secondary side from this transformer this way. So this is the output that goes to these connectors, and this is the input that has the mains connection over here. So let's take this board out and see what caused that fuse to blow. So let's cut this tie rod over here, and we have the board out. So now, as you can see, this is the fuse and it is connected here. So after the fuse, it goes through filters, capacitors and inductors over here, and then it reaches to the bridge rectifier, this one. So let's test after the bridge rectifier. So here is the rectifier. The inner two pins are the AC side that comes from the mains, and the outer pins are the DC side. The DC side is not shorted, and the AC side is not shorted either. So it's not shorted. 0.5. So this is the ground side. To know the ground side of the primary side, you can use a diode mode and put the positive or the red probe to one of the rectifier pins. So let's try this one. If you get a voltage drop 0.5 in both the input side, the AC side of the rectifier, then this is the negative side. If we put the negative probe now in this side and we use the red probe to test the middle two pins, which is the AC pins, we get 0.5 voltage drop. So this rectifier is good, and now we have this line is the positive line and this line is the negative. So we can also know by checking this capacitor. So the capacitor has this gray strip over here, which indicates the negative side. So the negative side is this way, next to the fuse. So here's the fuse, and this is the capacitor. So this line or this pin is the negative. If we check from here to this, we should have continuous. So it's the negative side, this one. And the positive side is this one. And we have a diode or what over here. So after this, it goes, after the bridge rectifier, it goes to this inductor and then goes to this PTC, and then after this PTC it goes here to this diode, and after this diode we should have the positive side. As you can see, it's there. So this diode is okay. And as long as this diode okay and there is no short at the output of the rectifier and the rectifier is good, I think that there is nothing wrong with the primary side and neither the secondary side. So that fuse may be blown by a surge or something. Okay, so let's test these diodes while we are here. This one, okay, good, they all are good. So let's test these transistors. We have 3 transistors and 1 diode. So the diode is over here and it is good, 0.4. This transistor, it is good. This one, it is good, and this one. So we have, it's not a short because of this resistor. This resistor is connecting the base and the emitter of this transistor together, so it's not. As you can see, we have 0.04. If we go to resistance mode and we check here, we will find it 62, 64, 65, 66, 67. So this is not a short. This is because of this resistor. Okay, so I think we just need to change this capacitor, or I mean the fuse, and check it. Once I change this fuse, I will use a series lamp to connect this to the mains to avoid anything. If there is anything shorted or anything that I didn't notice, which is still causing this fuse to blow, I will use that series lamp to avoid this power supply to blow up or anything to blow up. Okay, so I will put it back again. I will replace this fuse and I will put it back and we will test it together. Okay, so here is the fuse. It's a bit smaller, but the value is the same. If we go under the microscope, it's 6.3, as you can see, 6.3 amps, and also it's written over here 6.3, as you can see over there. So it's a 6.3 amps, 250 volts AC. So I will use this one and we will test it together. Okay, so first let's test this fuse if it is good or not. This fuse is good. As you can see, we have, it's short, so the fuse is good. I will replace it and we'll check it together. So the fuse is out. Let's wick it. Okay. So let's test it again if it is good or not, and as you can see it's not, and this one is good. So let's install it and see if this will solve our problem. Okay. So let's test it now and see if it will work or not. As I said, I will use a series lamp to limit the current. Okay. But first, let's install it in its case. Okay. I will install 2 screws for now. Okay, so let's connect it. Okay, now so I have it connected to the mains through that series lamp over there, as you can see over here. So let's turn it on. The lamp flashed twice, I don't know why, but let's test if there is an output. So if we go to the auto voltage mode, if we test the green wire to ground, we have nothing at all. Oh, this is not the green wire, this is the green wire. So we have 5 volts, yes, so I think it will run now. If we check the 12 volt, I think this one will be available only when the power supply is on. So we have, yes, we have 12 volts, so it is working. Let's short the ground and the green wires, these two. So the power supply is on and the fan is spinning. I don't know if you can see it, but it is spinning over there. If I remove this jumper wire, so it is working right now. So as you can see, we managed to fix it just by replacing that fuse. So that fuse maybe get blown by an electrical surge or something, or maybe a lightning hit. So that fuse is there to protect the power supply if there is anything happened in the mains electricity. So there you have it, we have fixed it. Thank you for watching. I hope you can like and share my video. Thank you so much. See you in another video.